Hey, I'm Marty, and today I'll be talking about the three basic ways to treat groundwater. First off, groundwater is basically any form of water that collects from rivers, lakes, and precipitation and seeps into the ground where it eventually reaches an aquifer, which is basically just a holding tank for water. So the three basic types of groundwater treatment are biologically, chemically, and physically. So first off, we have bioremediation. There's a lot of ways to implement biological aspects. However, these are the most common: bioaugmentation, biosparging, bioinventing. They kind of go hand in hand. And phytoremediation. First off, we have bioaugmentation is basically when you use genetically modified or naturally occurring bacteria that have unique profiles, metabolic profiles, to decontaminate the water. Biosparging and bioinventing, they both use oxygen to rid the contaminants. Biosparging, you pump oxygen and nutrients into the soil, as in bioinventing, you have huge blowers that pumps oxygen into the saturated zones to get rid of hydrocarbons and petroleums and things of that nature. Phytoremediation, it's actually naturally occurring. It's basically the process of where trees suck up water through their roots, and the water comes from the aquifer, so that continual pumping keeps the water not stagnant. So there's a lot less microorganisms and things of that nature compared to surface water, which has a lot. Treatment by chemical means, we have carbon absorption, ion exchange, precipitation, and in situ chemical oxidation. Carbon absorption, I'll talk a little bit more in the next slide because I have a picture that goes with it. Ion exchange, however, is basically you have a resin bed and you have water passing over the resin bed, and as the water passes, the contaminated water and the resin ions will switch to produce purified water. For precipitation, you have heavy soluble metals, and they're being converted to insoluble metals to be later filtered. And in situ chemical oxidation is when you add reactive chemical oxidants into the soil, and it's actually very effective. It takes about 2 months, but it drastically reduces the amount of microorganisms and pathogens in the water. So for physical means, you basically have a lot of types of filtration. We have a polypropylene cartridge that actually goes in the micro ultrafiltration unit. Polypropylene is just chains of propylene that basically make a membrane. The membrane usually has a diameter size of 1 to 2 microns. So we have these huge tubes with these polymer linings, and water is being pumped down, and the contaminants will generally get stuck. So that's a good thing. However, fouling occurs, and the company will have to backwash those units every 20 minutes, every hour, depending on what you're dealing with. In reverse osmosis, it's the opposite of osmosis. Osmosis is driven by a concentration gradient. And concentration gradient, so for example, we have a U-tube. One has saline solution, one has water. Naturally, to reach chemical equilibrium, the salt water is going to move to the water side, and the water is going to move to the saltwater side until it reaches an equilibrium. Well, reverse osmosis is kind of the opposite, where you're applying a hydrostatic pressure to one side to go against the grain. And then carbon adsorption, we have these huge tanks that are lined with activated carbon. And as water comes in, carbon's neutral. The contaminant ions are either positive or negative, depending on what the contaminant is. And they'll stick and bind to the carbon. And the minerals, they just flow right through, and that's where mineral water and a lot of the purified drinking water comes from. So it's a lot like ion exchange, but it's a little different. So the pump and treat method is the most widely used method in the US and probably most places, to be honest. It's basically where you find a site that's close to an aquifer, you pump that water up to a holding tank, and then you treat it by means of chlorination, ion exchange, filtration, and then produce pure drinking water from it. So some of the other methods are chlorination and ultraviolet disinfection. Everybody knows what chlorine is. Chlorine is simply, it's in our pools, it's in our hot tubs, it's in our water. Up to 500 parts per million is what they deem safe, which is the 0.5 milligram per liter residual. Well, anyways, it does a really good job against most bacteria and viruses. However, it's not 100% effective. It's not very good against cryptosporidium, which is a type of bacteria that actually caused the 1993 Milwaukee water crisis, where 200 people actually died. And UV disinfection, it's basically you have long tubes, water's coming in at a given flow rate, you have a UV lamp that scans up and down, and it works pretty well. It's really easy to maintain. However, if there's any free-floating particles, it doesn't do the best job. And both of these methods require some form of filtration, so the cost can add up really fast. So here are some references where I obtained my information from. And just to reiterate, today we talked about how to treat groundwater by means of biology, chemical means, and physical means. And there's no really preference of which way, as long as it's, for the most time, we're talking about what the company wants, so like the highest profit, but also the safest. So that's my presentation on groundwater remediation. If you have any questions, comments, or concerns, please address them now.